Recording in progress.
Hello, my dear students. So this question is from Mechanics J Advanced. It is this question asked in 2007, and it was in paper 2. So let's have a look of the question. What is the question asking you? It is asking you that a particle moves in XY plane under the influence of a force such that its linear momentum is pt. P is a linear momentum which is function of time here, that is mentioning you like a and then I cos kt minus j sin kt, where a and k are constants, the angle between the force and the momentum. So the question, it is given you the linear momentum. That linear momentum is function of time here, and this linear momentum is mentioned here a, and it is in I direction. We have cos kt. This is the I component of the linear momentum, and then minus j component here it is. This is sine kt, where t is time and then k and a are given here. It is constant, and we are looking for finding the angle between force and the momentum. So how we can find the angle between the force and the momentum? So we know that how to find the angle between the two vectors. If two vectors, you know that it is given to you, and to find the angle between the two vectors, we can use the dot product over there. So, but here, how we can use the dot product, because we don't have the force, but we have one relation with the force and the momentum that we know. What we know is force. If a linear momentum is function of time, it is given to you. This is function of time. So we can relate what will be the force as a function of time over here. This will be, it is dp by dt. So if we differentiate the linear momentum with respect to time, it is force only. That is the Newton's second law. From there, you have learned this one, that force will be rate of change of linear momentum. So what the function we are having, we are just differentiating that function of linear momentum. So a is the constant here. Only we have to differentiate the cos kt and then sine kt, that we have to differentiate. So this is a, I'm writing accordingly I. The differentiation of cos, so it is not direct cos theta given to you, it is cos kt given to you. So it will be minus sine kt, and by the chain rule we have to multiply here k again. So this is the first function we are having, first term of the force function, and then again this sine differentiation. So the differentiation of sine is cos theta, so here it will be cos kt, and then we multiply here another chain rule format, that what is the coefficient of t, that will be multiplied over here. You know it very well. This is very easy kind of question. So from here you can see k we are having here also, and here also we can eliminate, we can take the common of k as outside, it is ak, and this is in both term we have minus here. So I'm writing accordingly, this is I, then we have sine kt, and then we have plus j, and here it is cos kt. So it is like this. This is very easy, where you know that how to differentiate, and then we can relate it. But there is sign of minus here, so we have taken minus as common here. Accordingly, I have written this one. Now, on the basis of this, this is force and this is linear momentum. So to find the angle between linear momentum and the force, that is asked in the question, that we can write cos theta is equal to, it is f dot p divided by modulus of f dot modulus of p. This I am writing on the basis of how you have written the dot product between the two vector a dot b, and if it is a dot b, we are doing the dot product between the two vectors a and b. It will be modulus of a, modulus of b, and the cos theta, and on the basis of that you can write it is the same thing I have written. So first, this I am considering equation 1 here, and this I am considering equation 2. Once we do the dot product of equation 1 and 2, that is the numerator part over there, and on the basis of that we can find out what will be the cos theta here. So what is the force here? If we'll do the force, this I dot with the I here, it is 1. So it will be, we have sine kt and cos kt, I dot I is 1. So the first term we will be getting here the coefficient a, and ak, it will be multiplied outside minus we have. So it is minus of a square k, and the first term I dot I, it is 1 cos kt sine kt. So it is cos kt, and then we have sine kt, sine kt. This is what we are having. Then after this, we can see here it is 1 plus, this plus, here it is, and here it is minus. So first term displacement, linear momentum we are having minus, and this force we are having plus. So it will be minus here. So that minus term will be there. So here it is minus. And then again, you can see here it is sine kt. And if you multiply with the cos kt, it will be sine kt j dot j. It will be 1. Again, it will go for I dot j, it will be 0, j dot I, it will be 0. So I'm just writing the one which we are getting the dot product it is. So it will be, it is sine kt and divided by, multiplied by cos kt and divided by the modulus of force and the modulus of modulus of force and the modulus of linear momentum, that we can see. Now you can see here that this force, this numerator part is 0, this and this both, here it is same, it will be 0 only, because the numerator we are not having, it is getting cut, so it will be 0. Cos theta 0, it means that what we can say about the theta. So theta will be, here it is pi by 2, or we can say 90 degree. So this is our result, and I think this way we should solve this question. Just whenever it is asked the angle between the two vectors, this is the easiest way to do the dot product between the two vectors. And on the basis of that dot product, we can find out cos theta, and on the basis of that, we can find the theta. So this is the question you can see here. In this question, you can see here, we have given two columns. This is also question from mechanics only, and asked in J Advanced 2007. And in this question, it is mentioned you four options are given in column 1, and the other four options are given in column 2. What is the question saying? Let's see it is. So column 1 describes some situation in which a small object moves. Column 2 describes some characteristics of these motions, match the situation of in column 1 with the characteristic in column 2, and indicate your answer by darkening appropriate bubbles in 4:4 matrix given in the orders. So what the question is, it is matrix kind of question. You can see the first option given in column 1. Let's see. The object moves on the x-axis under a conservative force in such a way that its speed and position satisfy V is equal to C1 and C2 minus x square, where C1 and C2 are the constant. If you proper analyze this relation of velocity, speed, and the position, then you could have think about this relation like this. Let's see this, how we can think this in easy manner. So the velocity speed relation with the constant, it is position given to us, it is C1, and the other option, it is C2 minus of x squared. So here V is the speed. If you compare this equation with the equation of SHM, then we have V is equal to, here we have A, sorry. If you compare this equation with the SHM equation, here we have V is equal to omega A square minus x square, where omega is the frequency of angular frequency of SHM. So if SHM is happening, let's suppose this I am considering mean position, this is extreme position, here also we have extreme position. So if a particle is moving, this amplitude we have from mean position to extreme position, this is called amplitude. And let's suppose I consider any position between the amplitude from mean position to between any position, here it is. So what will be the velocity speed here, that we can write in terms of omega, amplitude, and the position here. This relation we know it. So if you compare this relation with this one, we can write this relation like this way. It is C1 and then C2. We can see here, this is what we have the omega comparing to C1 only because C1 and C2 are constant. So it will be C1 and C2. At the place of C2, you can compare this C2 as the A square and X square we have. So this is what we can say here. This will be, if we compare the equation, what I have written here, this side it is, this equation and this equation, if you compare, it is resemble. How it is resemble? That omega we can compare with the C1 value, and we can see here A square is the C2 here it is. So what will be the amplitude? It is root under C2. And the position is already X only here also X. So this, if you see this equation, what is mentioned in the first option, we have the object is moving in this one, and the right side option, 4 option, how to match the 4 option, 4 any option here it is. It might be possible that we could have the 1 option or 2 option for a single column here, single options. So let's see the object executes simple Arduino. So this is matching over here. The object does not change its direction. We know that in SHM there is change in the direction. The kinetic energy of object keeps on decreasing, which is not possible. You know that speed is decreasing here. It is at extreme position, it will be speed will be 0. But after extreme position, if it is moving towards the mean position, again speed will start increasing. So this option is also not correct. Object can change its direction only once. So for option A, we have only P to be correct here. So this, for this option, that option A, we have only P column to be matched here. Now going to the second option, what we have here, it is that the object moves on the x-axis in such a way that its velocity and displacement from the origin satisfy v is equal to minus kx, where k is a positive constant. So here, this is the second relation given to us, that this A option I'm writing, this is for B, that velocity is equal to minus k into x. Here you can see this relation means this side we have velocity and this side we have related k is constant here. So when x will be 0, that velocity will be 0. It is. So it means that it is moving in which direction? It is moving from, if you consider from the negative direction to coming towards the origin, then what happened here, that if it is coming towards origin, this origin we have negative. So once it is getting closer, here it is, the value of x from the origin is getting decreased. So once the value of x will be getting decreased, that we can say that a speed will get decreased. So when it is coming closer towards the origin, its speed will be decreasing. If a speed will be decreasing, what does it mean? That kinetic energy will be decreasing. So this is the factor here we are having. We can relate this one, that the first thing is it is not executing SHM, because velocity relation for SHM we have like this kind of relation, it is, that is not the option. Then the second option, you can see the object does not change its direction. So this, what it is, object is moving in this direction, on this direction only. So if it is moving from negative direction onward, if you consider here, so it is not changing the direction because v is equal to minus of kx. So it is moving in particular direction. So this, the object is not does not change its direction. Then the next option, we have the kinetic energy of the object keeps on decreasing. This we have already seen that the, if it is x is getting decreased, so a speed will decrease, and due to which the kinetic energy will decrease. So for B, we have option, for B, we have here 2 options matching. One is Q and another is R. So for B, we have Q and R. Next, we have the C option. Let's see what is given in the C option. In C, it is saying you the object is attached to one end of the massless spring of a given spring constant, and the other end of the spring is attached to the ceiling of an elevator. So it is a spring and block system which is attached in the lift here, elevator here. Initially, everything is at rest. The now elevator starts going upward with constant acceleration A. So when acceleration A is given to the elevator, there will be some extension in the spring over there. And what is happening here, that the motion of the object is observed from the elevator itself. So during the period, it maintains this constant acceleration. So in this situation, what analysis we can do here is, if it is connected, so this is the, let's suppose this we are having the ceiling, and here the spring is attached and block is there. And a man is there, which is there inside the lift only, and lift starts accelerating up. So when man is observing on this block, there will be pseudo force act on this one. So if pseudo force will be act on this one with respect to this lift frame only, so in that condition, this there will be a motion which will go to and fro kind of motion. This what we can say here is SHM motion will be there. So in this situation, when the pseudo force we consider, because this we have to consider, this is mentioned to us in the question that motion of the object is observed from elevator itself. So when we consider the motion of object from elevator itself, it means that we are analyzing the situation from an accelerating frame. So we have to apply the pseudo force over there, and on the basis of pseudo force, this will be considered that there will be the object executing the simple harmonic motion over. So this C also we have here, direction of object. Object does not change direction. This is also not possible because it will go up and it will come down also. Kinetic energy, this also not same, and the object can change direction once only. This is also not. So only possibility for the C option we are having is P only. Now the last option we remain with, that is the D option. So in D option, it is given to you, the object is projected from the Earth's surface vertically upward with the speed 2 gme by re under root. So where g is the universal gravitational constant, me is the mass of Earth, and re is the radius of Earth. So that is given to you. And it is asking you that if the radius of Earth re it is, neglect the forces from object other than the Earth. So other forces we have to neglect over here, that no air drag is there, nothing is there. So only we are considering the force of the Earth only on that object, which is getting projected from the Earth's surface, and its speed is given to us 2 gme by re. So what is the speed it is given to us? It is 2 gme by re. Once you see this result, you could have think like this. We can write like this is root 2, and we can write like this also 2 gme by re. And on the basis of this, this is root 2, and this is escape velocity from the Earth. Escape velocity from the Earth. So what we can see here, the velocity, what it is given to us is escape velocity from the Earth, and its direction is not getting changed. So the object does not change its direction because it is escaping from the Earth itself always, and only force is acting from the Earth on the object which is getting projected here. So when the force is acting in downward direction and the object is going upward direction, means away from the Earth's surface, so what happened with the speed? It always start decreasing. It always start decreasing. So once it will start decreasing, the kinetic energy will decrease, and this also you can say the object does not change its direction because it is moving in escaping direction from the surface of Earth. So what we can say here for D option, we have this kinetic energy will be decreasing and the object does not change its direction. So the option in this Q, and we have Q and R. So object, this D is, we are having Q and R. So this could be the appropriate result, which you should mark that if matrix is given to like A option is having P, where A is the situation which is resembles with the situation of the SHM. So we can relate that it will be in SHM. We know that kinetic energy always changes with respect to the position, and we know that the direction always changes. It is not the once only the direction will change. For the second option we had, it was velocity relation with the position, and that was negative of the position here. So in this situation, once the axis is getting closer towards the origin, at origin it will be 0, the kinetic energy will be 0, speed will be 0 at origin. But once it is coming closer to the origin, the x value from the origin is getting decreased. So once the x value from the origin is getting decreased, the speed will decrease, so kinetic energy will decrease, and the direction is not getting changed because it is moving in this direction only. So in this situation, we can say that the direction is one direction only, and the kinetic energy is decreasing. For the C option, we had this spring balance, spring mass system, which is in elevator ceiling attached. And with respect to elevator, we had to analyze that one, and that you can see that it will be a SHM kind of motion if a man is there in the inside the elevator. And the option D, what we had, it was the relation, speed relation of an object projected from the surface of Earth, which was given here. And on the basis of that, we get idea regarding it that this velocity is the root under root 2 escape velocity, what the velocity we had given. And only Earth is getting only Earth is applying the force on it, this one, and it is having this velocity. So due to this force, the speed will start decreasing, and force is acting in opposite direction of motion. Other forces are not observing here. We have mentioned in the question that other forces are not over there. Neglect the forces from the object other than the Earth. So only Earth force is always towards the center of Earth, and the body is escaping from the surface. So speed will decrease always, and the direction of motion also, you can say it will be away from all center, away from the Earth only. So direction will be once this only. So I think that this is clear to all of you that how you should have think. This is the paper of 2007 at JEE Advanced. So in the coming video, I will be discussing the other questions. Thank you.